I think I want to bring to your attention this new source. I mean, for the helpful in demand planning. I mean, in addition to things like that we've talked about already, there's also another trend, and that trend is called the Internet of Things. And I've actually worked with Internet of Things with a major coffee maker, coffee uh, uh, producer, not producer, an actual coffee maker who makes some of the leading coffee machines in the industry right now. Probably unbeknownst to you, there's a tremendous amount of data that is being captured. And now they're moving into an environment where the data is being pinged. And the data that is being pinged is things like how many cups of espresso do you make versus coffee? How do you like your coffee? What kind of coffee are you making? What's the frequency? What days do you make them? These kinds of things. Nothing personal, but collecting information. We also have Amazon, which through their dash button is collecting when you do laundry, how much laundry detergent do you use? Gives you a chance to reorder it. The same thing is true with refrigerators. So the whole idea of Internet of Things, and by the way, it's very true of things like industrial fleets. So forklifts are a classic example. They're the newer trucks do have a lot of Internet of Things capability on it. And so I thought we'd just kind of very quickly, and I mean really quickly, just kind of go over an example from MIT, from some work that they did. But I think the big thing is be aware that the Internet of Things is a source of demand, and that in so doing, particularly if you're in the servicing business, the services business, understanding that the units that you're going to service are providing data around what needs to be fixed before they even call you. There is a record, or you may be receiving data on use, application, and even sending out exception messages as saying, hey, this is what's wrong. And so when you come out to service the unit, make sure you have this particular part or parts or assemblies or whatever the case might be, so that when you come out, you're in a position to fix the problem and don't have to come out a second time, which obviously causes disruption within a warehouse if a lift truck is down for extra time or extra hours, extra days, while a part is ordered or whatever the case might be. On the newer fleets, you will know that if you are mining that data or actually receiving that data as part of your service agreements. So this is becoming more and more of a available technology, and it extends way beyond just demand. I mean, we're looking at, from a visibility standpoint, we're looking at Internet of Things in terms of sensors in containers, in trucks. This is different than GPS now, but on the trucks themselves have sensors which are sending out information on hundreds of different um, uh, electromechanical conditions that's going on in that truck, and it's being sent back to either a fleet management location or something. So in the event that the truck breaks down, there's all this history ahead of time in terms of what's going on or what's happening. It's being used for safety regulation. Um, uh, Electronic logging is being done on the Internet of Things. So there's many applications within the supply chain on this. One of the newer ones is they call it M to M, so mic to mic, if you will, M to M. And it's basically a sensor that's going to be placed in the container, and it's going to be accessible through a GSM information backbone or satellite, and it will be sending off a signal that will say this container, the temperature is getting too hot in this container, or the humidity is getting too hot in this container, and the shipper or the consignee, whoever has their finger on the button, if you will be able to send a message to adjust the temperature, so when the product arrives, it's not damaged or compromised in any way. Um, this is in test right now. But that's an Internet of Things type application with game-changing technology. So you don't have to wait for it to get here and find out that it's been exposed to a high temperature. You can actually manage it in transit and make sure that that does not occur. So that is an enormous step forward if the company has a capability of being able to use the information technology and have the tool set and the toolkit necessary to tap into that and manage it from your end. So let's take a look at this one example. Again, service parts. This is a classic situation of what you want to know. I mean, when it automatically reorders certain things for you, whether it's a refrigerator filter, it gives you the opportunity to do it if you choose to do it. Amazon's taking this further than anybody with their dash button. They have this on several different kinds of appliances now. It's a collaborative effort with the supplier, but it does make things obviously much more easier for the consumer. So the Internet of Things, I mean, this is a big market in and of itself. In 2015, there were over 80 acquisitions closed. There were deals made in this space. This is a very hot space for acquisition, not too dissimilar to autonomous vehicle planning and things like that too. I mean, it is a market. There's an installed technology base now. It is increasing. There's no question about it as more and more companies, particularly again on the industrial services side, whether it's an air conditioner or a furnace or whatever, a water heater. You know, the application here is very real, where it can even send. It probably could, with the right technology, send a message off to Liquid Gas saying we got a gas leak, rather than waiting for you to have that happen. So it's going to have a sensor that can send that off and say something and even potentially even shut it down. So, you know, these are very positive steps that are being taken. I don't know if you knew, but Mattel has an IoT Barbie doll, which I don't know anything about, but they supposedly have one. Again, we've talked about laundry, kitchen, and countertop appliances, whether it's your coffee maker, whether it's your microwave, whether it's your juicer, whatever it is, there is information. Your vacuum is connected back into a GSM network in order for it to manage its location. And there's a lot of financial activity now bringing this technology online. And I think basically what we're seeing is it's coming from the tech side, and the tech companies are being pushed and pressured by their investors and by the markets to really say, okay, this technology is great, but again, very much like AV, but how do you address the security, and how do you address the connectivity, and how do you manage that? I mean, if you think about autonomous vehicles, for example, we know Tesla got hacked. Tesla asked to be hacked and got hacked. So what's the key? What's going to happen from not only the technology standpoint within Tesla, but also what are the regulators going to say? How are they going to protect the ordinary driving community from having their car hacked and taken out of their control? I mean, it just could be a switch that allows you to convert from one to the other if that kind of thing happens, or it automatically shuts down, or whatever it might be. So there's this whole idea on not only just the analytics that comes from it, but the back end, which is how do we manage the security and how do we manage the connectivity, and of course that creates new revenue streams. So even for the servicing companies, for example, if you're servicing forklifts and that forklift has this kind of technology on it, this can be a new revenue stream for you. Your service fee, instead of $150 flat, can be based on some other metric or some other kind of program that will make it it should make it, at the end of the day, it should make it less expensive because you have less downtime. So you're actually getting information that says you need to go out there before it breaks. And I think that's the important thing, is that you can go out and service what needs to be serviced, bring the parts with you and service it and minimize the downtime. There's always going to be downtime, but this is minimizing that and being, again, very proactive. And to do that, partnerships. So partnerships you're not going to find this kind of thing in an ERP, at least not now. So there needs to be, systems built, integration points designed. We mentioned this, that that an ERP is really designed within the enterprise. This is managing industrial fleets or appliances or consumer, whatever it may be. This is a different kind of connectivity that you're going to have. I can tell you that it can be done. It can be done in real time. It can be done in batch. It can be collected and then pinged at certain points of time. All these things are very possible. Again, privacy is going to be an issue, but there isn't. The ones that I've seen so far don't have any. There's no privacy issues associated with how many cups of latte you make and what size those cups are, by the way. So just so you know, they know that too. So the challenge is, as I said, security is a massive concern. So the C-level wants the cash flow. So you've got somebody saying, hey, here's another revenue flow, make this happen. You as the supply chain, and what comes out of that supply chain is going to be the demand for a variety of parts. It's going to be a demand from a consumer that will go into demand side, and then that then filters down into what was ordered, where do I need to have it, what machines are failing, what machines are not failing, and you're going to, and your parts, your service parts people are going to be looking at that and being able to better refine the inventory they need and where they need it, which gets into the case we have on Jefferson Plumbing, which is much along that line of having the right parts in the right place. So this technology allows you to, if you can harness it, allows you to get visibility into issues before they become a consumer issue, makes your service much more valuable, is a competitive advantage. There is a pushback. I mean, clearly this is not real sexy to do this, and consumers don't want to have to manage that interface. So it's going to be incumbent upon the designers to build those interfaces in. It's certainly whether they're automated, and if they're automated, the consumer would have to agree that they don't get Tide if they don't buy Tide detergent. So it just can't be one customer. It's got to be across the board, and that would probably be set within an app that says, when I'm running low on detergent, please replenish my Tide. And this is the size Tide I like. This is the fragrance I like, or whatever the case may be. This is exactly what Amazon is doing. So you're going to have to navigate screens. You're going to have to navigate screens on an app. But the number of steps are being reduced, and Amazon's taking the lead on it. So it's really a fascinating thing to look at, not only from a demand standpoint, but from an inventory management standpoint as well. So here's a case study from MIT. It was a master's thesis. This is a study right here. Installed base of machine failure prediction. So this is mean time failure analysis, what they're looking at. And what they were looking at was this, is that companies tend to overstock the inventory so that when the products break down, they have the replacement parts readily available. I can tell you in service parts, that's exactly what happens. You forecast that you're going to need X number amount of assemblies or whatever. But so depending upon how you procure them, the tendency is to carry a lot of safety stock, because if you need it, you really do need it. And if you don't have it, there's a good chance you're going to have to fly it, depending upon the size of the problem, which is going to cost money. So by looking at this, with the fact that we have connected products, the author said we saw the opportunity to analyze the signals to predict when the components are going to fail, and therefore they get a more sophisticated forecasting model. So it's exactly what I said. Whether it's whatever the machine failure is, it doesn't matter what kind of machine it is. The point is that these two authors came back with, hey, this really works. And I think and this is exactly what they came up with. Because they were getting this data, they were able to accurately predict the failures. So, and as a result of predicting the failures, they could take the safety stock out and lower the average inventory. The other thing is you don't go back and you don't go out and service an item that doesn't need to be serviced, rather than just say, okay, we're going to have a PM, a preventative maintenance, on all of your lift trucks and take all your lift trucks out of service for 2 or 3 hours. You come out and you work on the lift trucks that need to be serviced, and you're bringing the parts that come in. So when you look at past demand, you can start to see the machines that require additional servicing, perhaps. And again, you can minimize that supplier lead time because you know this machine has a tendency to blow this valve for whatever reason. So you want to fix that problem, but you also want to make sure you have that valve in stock wherever you need it, and only where you need it. You don't need it in multiple locations if the machine is breaking down, is only breaking down in St. Louis. So even, and again, they found out that even if we do a poor job, it's better than not doing the job at all, which is the case today. So you can gain benefits by just simply capturing the data and analyzing the data in terms of running it through some simple forecasting techniques to do that. So the other thing is, as I said before, and I've never worked with a device with this kind of technology on it, but I know people who have, and this is exactly what I hear back, is that because they already have the data coming in, whether it's a truck or whether it's a forklift or whether it's a compressor or whatever it is, the right parts come out generally at a higher rate than what they do without this data. So the amount of downtime is minimized. The uptime is maximized, the other way to say it. The time to resolve the problem is much less. You can forward stock in locations. You can make that. This is something that any good services company is going to want to do. They're going to want to carry this in their rep's trunk if they need to carry it in their trunk. And you can do a better job of not having to expedite inventory as a result. And because you're capturing what the actual defect is, you can do a better job in product design. Now this plays into the whole idea of plays into the whole idea of return management or reverse logistics, which we talk about in week 8. But this is very critical, is how the defect data that comes out of this kind of can be used to better engineer the product to begin with and avoid the whole thing. So Dr. Chris Caplice, who was just recently recognized for his contributions by CSCMP, and is a very interesting guy. They've come to this conclusion at MIT, and I can absolutely see how that's the case. So again, from a demand standpoint, as well as from an inventory and a demand planning standpoint, this technology is something that you definitely want to keep it in your consideration going forward. And can your company benefit from some type of IoT type engineered development? And could you use this type of data within your organization? So I just wanted to bring it to your attention because it's something you hear a lot about. It's out there, and you should, if you can have a chance to see it or have a chance to interface with it on the floor or whatever, please do so and let us know what you find. Okay, so that was it. Not very much. I'm sure you're glad about that. See if I can get this to come up, and we will stop.